Okay, so I just found out the most efficient method to solve this question. Question number 20, which says if resultant R of vectors P vector and Q vector is perpendicular to P vector and magnitude of P and R is same, then find angle between P and Q vector. Okay, so according to the question, we're gonna mix a diagram here. It says resultant of R vector. So let's consider that P and Q is perpendicular to P vector. Okay, we'll take R vector here and then it is perpendicular to P vector. The Q vector must be here. Okay, so now what we will do, we will shift. Okay, so first of all we have to find the angle between P and Q. We all know that the angle between them is the angle between their tails, which is theta, this whole angle. Now we're gonna shift this Q vector parallelly to form a right angle triangle. We already know that this is 90 degree and its magnitude is same. So we are going to shift this Q vector from here to here, and now simply we are going to just apply Pythagoras theorem, which says r square plus this is okay, so this is P plus P square is equal to Q square. We are talking about magnitudes here, and we all know that here r and P is equal, so we're just going to write 2P square is equal to Q square. Now P by Q is equal to 1 by root 2. If you solve and then take square root, and now we have to find the angle between P and Q. We know that P by Q, that means P by Q, base by hypotenuse, it's cos theta. Cos theta means we are finding this angle. Okay, let's call this as alpha. Cos alpha is equal to 1 by root 2, that means alpha is equal to 45 degree. And from this relation we got to know that here the angle is 45 degree, means here if we will make the Q vector, it's 45 degree, but it is not the angle between P vector and Q vector. This is the angle between P vector and Q vector. So 180 minus 45 is 135 degree. This is 135 degree, and this is the angle between P vector and Q vector. I know I messed it up all using the overwriting thing, but I hope you understood the thing. I think this is the most easiest way I ever found, and I just created it using my own mind. I hope you liked it.